if I want to write the equation of a quadratic and I just want to get it into vertex form. So I know it's kind of annoying to do graphs in your notebook, but we're not going to do a ton of them. So just give yourself something super simple and then identify what your vertex is. Okay, so let's say I want to write the equation of a quadratic that looks like the following. Students is that I can't teach you all of quadratics in the time that we have. It's not our standard to learn everything we need to know about quadratics. Okay, again, we're looking at sort of just this basis. As you move forward and you go into second year algebra, you will look at much more complex types of graphs. Okay, but for us, we're sort of sticking in this limited world to where A is 1 or A is -1. Okay, we know that A is 1 or -1 when we meet that matching pattern we've been talking about. Over 1, up 1, over 2, up 4. Okay, so I guess all of the problems I give you are going to meet that pattern, but we want to check to make sure before we just assume that it's that type of quadratic, because eventually one day it won't be. Does that make sense what I'm saying? Okay, I'm not going to give you something that's ridiculous and say, write the equation of this quadratic and it be a type we haven't talked about. All right, so we always sort of want to check at this point in time if we are writing the equation of a quadratic that it's in the format we know how to deal with. We only know how to deal with quadratics that have this pattern of over 1, up 1, over 2, up 4. We're in that format, so we're good. Okay, that means we can then fill in kind of squish that in. Right, we can fill in our numbers for our vertex form, where our formula has been y equals a times x minus h squared plus k. You can get all of those numbers by only knowing your vertex, right, and what the parabola looks like. So if your graph isn't super pretty, that's okay. You just need to know the vertex. So if we look at this picture, is A going to equal 1 or is A going to equal -1? 1. How do we know that A is going to equal 1?
There's no negatives.
Because it opens up. Okay, because if I have a blank, for example, on your test, which I will, that is asking you to fill in a value of A. And the value of A is 1. It does not count if you leave it blank. You cannot say to me, but Mrs. McKinney, no number means 1. Okay, there is a blank. Fill it in with something. Put a 1 in there. Okay, what's our vertex on this parabola?
3, or 2, 3.
2, 3. Okay, so what's our h value going to be? 2, right? H, k. Is this going to be -2 or +2?
Plus.
No, minus, because, yeah, you take that.
Right, the formula says subtraction. It should look the opposite of the number that we pulled out. Okay, what's our k going to be?
3.
And it's a plus. And that's all we have to do. My students are like, sweet, no problem. Okay, no problem if we need an answer in vertex form. Okay, but what happens if we look through maybe a multiple choice problem and this isn't any of the options? Okay, we also might need an answer in standard form. So let's say we have y equals, I'm just writing down the same problem, I just have to turn the page. X minus 2 squared plus 3. But let's say we need our answer to be in standard form. We need our answer to look like y equals ax squared plus bx plus c. What could we do to get this into standard form?
Take out the parentheses.
Get rid of those parentheses?
Yes.
How do we get rid of parentheses for x minus 2 squared?
Take the square root.
Simplify it and multiply those out. That's why I just had you practice that. So x times x is x squared. X times negative 2 is
Negative 2. Negative 2x. Negative 4. No,
positive 4. Okay, so that becomes x squared minus 4x plus 4. But we're not done yet, because all I did was simplify the x minus 2 squared.
Now you.
So now I still have y equals 1 times x squared minus 4x plus 4 plus 3.
Add like terms.
Okay, so does this being 1 being multiplied times any of this matter?
No.
No, so I'm going to write it down as a new step, but you wouldn't really need to, because distributing that 1 just keeps this as x squared. Right, I'm really doing that. Minus 4x plus 4 plus 3, and then just like Olivia said, we have like terms we can combine. So what is 4 plus 3? 7, and we end up with y equals x squared minus 4x plus 7. So it's a lot of math work in terms of getting it simplified, but it's not hard work. Are we okay there? I'm just letting people finish writing. Is that a 7 or a 1? A 7. Right. I'm putting these two values together. Okay, there.
You're good.
Okay.
It's okay.
Okay, so we're only going to do one more. Let's say we have this.
That's good. Yeah. Backwards.
So again, right, you don't really need a perfect parabola, enough that you can like just name your vertex. It's not a big deal. Okay, so if we look at this parabola, what is A going to equal? -1, right? So we need y equals -1. Okay, that's just not very clear. Let me try that again. What is our vertex on this parabola? Okay, so 1, 2, 3, 4, negative 4, positive 1. So when we go to plug this into our formula, this is going to be negative 1 and in parentheses, x what?
Wouldn't it be plus 4?
Plus 4. Right? Because we'd really be saying minus negative 4, which would turn into a plus 4. Then what?
And then you're gonna
Plus 1. Because that's my k value. Now, this is fine if this is the format of an answer we want to get it. Okay, but if we need to get this answer into vertex form, what would we need to do? We would need to start simplifying. So what do we want to simplify first?
The x plus 1.
Yeah, x minus 4 squared. Because order of operations, right? PEMDAS parentheses we deal with first. So x plus 4 times x plus 4. So we multiply this out. I mean, at this point, we should be able to multiply two binomials and feel pretty good about that. Okay, so this turns into an x squared plus 8x plus 16. But we're not done because this is still in parentheses with the negative 1 out in front of it. Plus 1. So what am I going to do next?
Distribute the negative.
Distribute the negative 1. Then what am I going to do?
Add the 1 to the 16.
Right? Combine like terms. And so this would be the answer in standard form.